So previously we talked about delta x and delta y, change in x and change in y. And the change in x is just how far, when we travel from point A to point B, or whatever we want to label our points, how far to the left or right did we land once we stopped. That's change in x, that's delta x. Delta y is simply how far up or down did we land from where we started. That's our change in y. And we looked at them on a grid and we just kind of counted spaces, but we might not always have the grid right in front of us. We might not always be able to draw the grid. What if we just had the locations of the points, the coordinates? Could we calculate what change in x and change in y are? And of course the answer is yes, or else I wouldn't be explaining this to you. But before we do that, I want to talk real briefly about change, right? When things change, or how to calculate change. Okay? If I have, say for example, I have some donuts, right? These are my badly drawn donuts, okay? And I start with 4 donuts. And then I add an additional, say, 3 donuts, right? I end with, end with 7 donuts. I start with 4, I add 3 more, I end with 7. If I want to calculate the change, if I was just given that I started with 4 and I ended with 7, and I want to calculate the change, I would go end minus start equals change, or 7 minus 4 equals 3. End minus start equals change. Maybe on the other hand, I started with, say, 5 donuts. So I start with 5 donuts, and then maybe I eat 2 of them. So I end with 3 donuts. And if I want to use my start and end values to calculate my change, I go end minus start equals change. 3 minus 5 equals negative 2. You might ask, what does that mean, negative 2 donuts? Well, it means that the change in number of donuts was negative. So that means that donuts were taken away. We lost donuts, right? So here our change was positive because the number of donuts increased. And here the change was negative because the number of donuts decreased. So we've seen when we looked at change in x and change in y, we have a similar thing going on here. If my change is to the right when it's x, then my change is positive. So this change was 2 spaces to go from x is 2 to x is 4. The x value increased, so the change was positive. And the y value went from 5 to 9, so it was an increase of 4. The y value increased, so the change was positive. But down here in this example, the x value went from 6 to 3, so the x value decreased, just like the number of donuts decreased, and so the change was negative. And also the y value went from 6 to 4, so the change was also negative. The y value decreased. So if we want to calculate that, and we can do it for these 2 examples here, our change in x is the same as we calculated with the donuts. It's end minus start. So if we traveled from x equals 2 to x equals 4, our change in x would be 4 minus 2 is 2. And our change in y would be 9 minus 5 is 4. End minus start equals change. Down here as well, if we had our change in x, we ended at 3 and we started at 6, so end minus start, 3 minus 6 is negative 3. And our change in y, we went from 6 to 4, so 4 minus 6, end minus start equals negative 2. And these are just a couple simple examples. You could use all sorts of complicated examples with crazy numbers. You could go negative with the x's and y's. I could have points over here where x or y were negative. And it always works the same. I just look end minus start equals change. So if you can remember anything from this, end minus start equals change.